boxes. All right, so since you're recording now, I'm just going to go back to the, oops. Why am I not? Okay. What is wrong with it? Okay, so I started out with the there's a title and things that we do at AI Institute. So the language has to interpret it in the context. For example, the same thing, if multiple people are ganging up together to hurt a person, that is a different aspects than just one-on-one interaction. Thus, when people do simple NLP on the text, it doesn't really work well, right? So early study in harassment on social media started out by using machine learning to classify whether this is abusive or harassing text or not. That really doesn't work well. Understanding the context in which the conversation happens and the type of issue that I've shown here on the top right, and variety of nuances of that is important. We had a very interesting work to study gender-based violence. And here we analyzed 17 million tweets from 5 countries, Philippines, India, South Africa, Nigeria, and USA, and studied harmful practices, sexual violence, and physical violence. So gender violence comes in different forms, but beyond the classification like this, there are a lot of underlying issues that you can study. So you do need to involve social scientists or psychologists or other appropriate disciplines as you study this kind of problem. And I think we had developed a tool called Twitteries, which became commercial product, and right now you can look up what it does by going to cognovilabs.com, and you can understand how different, for example, how in some country there is a lot more of harmful practices like FGM in Africa, while some other country has some other kind of violence. So we need to study, we need to understand really all the dimension of this topic, in this case gender violence, and then study that. And there are a lot of dimension in this study. We had spatio-temporal, thematic, people, content, network, sentiment, emotion, intent, analysis, right? So there are many aspects of this analysis that you can do on the content, and then understand how that maps to the problem that we are studying. Another example is emergency relief coordination on social media. And here you want to match, request for resources and offer for resources. So somebody says, where do I go to help? Or I can offer free help for, rebuilding somebody's house, or at least put the roof back. And somebody asks for help, saying, I'm here, I'm stuck, I need a rescue. We had actually used our social media platform Twitteries for in real time during 2012 Kashmir floods and many other such crises. And actual rescue happened using this kind of platform. So it's nice to actually build system that can be used in real time in the real world. In this particular context, there was a big challenge that the amount of content, let's say one example is that we extracted 2 million tweets during Oklahoma tornado. There were very severe tornado in part of USA, and overall in the context of this particular crisis, the number of tweets that deal with requests for help was around 1%, and ones that were offering for help was around 0.02%, extremely small percentage, right? So when you use machine learning techniques, there are issues with imbalance and many other issues that you have to handle. Again, in our case, use of domain knowledge played very critical role. So we would model all types of rescue concepts. We will model all type of help concepts. We work with UN on developing a humanitarian ontology, and then made this coordination in the context of that ontology. Understanding this toxicity, relatively new paper. Here we showed that the context and knowledge are very important. That again, just NLP kind of things that are primarily based on statistical learning or machine learning don't do very well. Here you need to really model the problem very well. The community, for example, the norms, the value, the social context, personalization, the semantics, the intention, the emotion, and then also the data may be structured, unstructured, multimodal data, and then you need to be able to really detect the toxicity with different models and see what works, why it works, and so on and so forth. All right, so now I'm going to shift my attention to some interesting things that are happening now. Basically, you all probably know that let's say the area of computer vision completely changed with the with the advent of deep learning. Similarly, now the language tasks are heavily dominated by statistical techniques, and more recently, the transformer model has essentially replaced has become the most used and prevalent approach to language tasks. Now, there are still many challenges with the language model. So as we try to understand the language, so there is a distinction that I make between natural language processing and natural language understanding. So natural language processing, a good example is language translation. And you really don't need to understand the semantics, especially if, if you have a very low resource language, you probably do. But for major languages, you don't. So far as you have enough data, you'll be able to do exceptionally good with regards to language translation. And some of the basic standard NLP tasks, I think you do very well with these language models and generative AI. But there are many other things where you actually need to understand the language. And so if you're doing classification or prediction, I think you do fairly well with language models, with transformer models. But if you want to do more complex things that involve you understanding of the handling of the abstractions that are in our language, that are in our understanding. I'll give you examples a bit later on, or analogies, or something that really requires you to understand. Then these models come. The current language models fall short. So the question I have in the bottom right: do world model semantics arise as an emergent capability of distributed semantics at scale? And so far the answer is no, not directly, not specifically, not adequately, right? And so here you need to be able to ground yourself into the real world representation that are typically in knowledge graphs. Um, so, you know, the language models, rise from the distributed semantics at scale, but they can, really still come very short. You can ask Obama, you know, uh, winning election in 2032, and it may, come up with an answer. It said, Obama just won election 2032 election while not knowing that, you're talking about a time frame that is in future, right? So just yesterday I saw a post um, by Moshe Wardi, who is a well-known computer scientist from UT Test, from Rice University, and he posted a conversation with Bard, where the Bard says, Moshe Wardi passed away at 75. He was a very well-known scientist, right? Now, this is, of course, fairly disastrous, right? As Moshe Wardi is living. And um, so there are many challenges. Challenges are very often related to low probabilities. And there are many things in the world where there is not enough data, where is, the probabilities that the model can build are very low, or sparse data, because of sparse data. And then the way these models are, they just mix up. If it doesn't, even if there is not a strong support, it will give you some answer, right? It's not created to hold back and know what it knows and what it doesn't know. Compared with the human, and human would say, this is something I don't know. At least, most humans would say, this is something I don't know. They won't just make up, right? But language models do make up, right? And the reason also is that if they don't understand, question is, what was the color of the white horse of Napoleon? Well, it already says, the question already says the color, but it will say, I don't know, or something else, right? So this kind of, it shows you that it does not understand that the horse has a color, and that white is a color type, is one of the colors, and that kind of knowledge that humans have, it doesn't have that, right? So it'll falter in such situations. Another example here is a question like this, in that it does not understand that there's missing information, and basically does not have common sense in this particular case. And the probability by itself is not sufficient. So here, yeah, it does not know human like, it can't really think the way, reason the way humans do. My student asked the question about me, like what, uh, is the name of my institute, and it just made up. It did get AISC right, but then it says Artificial Intelligence and Integrated Intelligence Systems Center. Well, there is no integrated, and I can now guess how it came up with that. For for about 2 decades, of the first 15-20 years of my career, I used to work in databases, in particular information integration. So I had a lot of work in integrating information and intelligence systems. Well, it saw some association with me, my name, and it just made up as it knows, it is expanding AISC, and then it did that. And then you follow by what institute does Amit Sheth belong to, and it says I don't know. So here are some of the challenges that current systems, current language models are particularly bad at. And I must note that this is all work in progress. So these models such as GPT 3 to 3.5 to 4 are improving substantially. There are things that they do to hide the limitations in a way and appear to have addressed the problem. And then there are other genuine new evolutions that are coming in those systems. And so you may look at 2 years down the road and this may not look as accurate as it is today. However, I want to note that this hallucination, the example of that Moshe Wadi, the safety, right? The thousands of scientists have advocated halting the AI progress, or there are many other problems that have occurred. For example, this thing, ChatGPT has made up the cases where, for a professor, it says that the professor was involved in harassment or some negative things, and it gives you access to people to articles, right? So again, just mix the things up. So right now there are major problems like that are there, and we need to address that. So from language processing to language understanding, deep neural networks do very, very well. As you need to go to language understanding, my proposition is that knowledge infused neuro-symbolic AI is currently an attractive options. And again, 2 or 5 years down the road, things would have changed completely. But this is what we can see right now. One thing I wanted to note is that while some people talk about explainability, they will be talking about system or algorithmic level explainability, not the user level or application level explainability. So my current view is that you do need the knowledge of the domain to construct explanation that is meaningful to the user. So I'll give you a simple example. In a medical text or healthcare application, you will need the clinical knowledge to construct the explanation that is meaningful to a clinician or a patient. You will not be able to construct that just out of the large amount of text, right? I'll show you some examples a little bit later on. Now, this ChatGPT is very, one of the very intelligent or very interesting thing it has done is to include this InstructGPT framework that involves humans. And so they said, no, I'll make the models larger and use instruction-based GPT. But that by itself, a current approach to that has limitations. So for example, if you take 40 humans, as ChatGPT did, to capture the human, breadth of human knowledge, well, that's not going to be enough. And my problem is with the way human knowledge is captured and incorporated into the model. Essentially, in the InstructGPT, you are converting human decision making into a label. So you're losing a lot of contextual information that human uses to come up with that label, and the label by itself does not capture enough semantics. So that is another interesting thing that's happening. I think if there is one thing from the technical side that I want you to take away is this slide, that language understanding is inherently more complex than language processing. And here is one reason. When you're listening to me right now, you are using broad variety of knowledge that you have. You start with the syntactic and structural knowledge, so lexical knowledge. right, at the bottom of the right hand side. Then you use linguistic knowledge. You then use common sense knowledge. You use broad-based general purpose knowledge. For example, you know that currently uh, Narendra Modi is the Prime Minister of India, and this is his second term. You know that knowledge, and then your domain-specific knowledge, things in UMLS for healthcare, for example, right? Or some ontologies, knowledge graphs that are purposefully developed for a particular domain. These, think of these as levels of abstractions. From, any language issue would require you to apply lexical understanding, lexical processing. But as you go up, for different applications, you're going to need different knowledge. So for medical domain as a whole, you may use UMLS, but for mental health specifically, you would have additional knowledge coming from DSM-5. And within the DSM-5 or other things, you may have PSQ-9, right? So capturing all that information is very is necessary to understand the language. And having a model. So one of the most influential paper in my view in the class of things that I work on was a 1945 paper by Vannevar Bush, As We May Think. And he talked about trailblazing, but connecting the concepts in context. That connecting the concept is easily done, and language models and all these statistical AI techniques does very well. But in context is the thing that it cannot do very well, at least today. And to construct the context, you do need to have a model or semantic representation or knowledge graph. When I showed you that slide on the toxicity, and that paper had a title of context, that paper, for example, argues and shows the need for modeling the context, without which, the language processing, howsoever sophisticated it is, howsoever big data corpus you have, is going to be, falling short. Knowledge graphs give you variety of things: explicit model of recency and common sense. They provide missing knowledge of entity relationship. They model world of as concept, as opposed to the language models that model world as probabilities. I don't want to say that the semantic approach is a alternative. I would say that they are both complementary, right, to statistical AI. That's why we talk about neuro-symbolic AI. Neuro part is the statistical aspects, the generative AI, let's say, and symbolic is the one where we have world model or knowledge graph or ontology and reasoning and symbolic models. And then you have user level explainability, as I explained, and safety constraints. So here is a class of systems that we work on right now. And in this particular, one area of work has been using graphs or knowledge graphs in neural network pipelines. And there are multiple, approaches to doing that. So you can read more about it in, a paper in 2019, Shades of Knowledge Infused Learning for Enhancing Deep Learning. And the shades are shallow, semi-deep, and deep infusion. So knowledge can be integrated with statistical AI by converting knowledge into a vector form and then merging the vectors. That is essentially the shallow infusion. But that does lose out a lot of semantics that is in the knowledge, but it is still somewhat useful. Semi-deep is taking typically the knowledge and adding it at typically the end layer to modulate the attention. So you are using the knowledge to improve the attention and hence make a better choices. Hence make better choices. And then deep infusion approach that we have presented is one where you are doing it, but not just once, but you're understanding that just like a deep neural network has multiple layers, and some of these layers can be mapped to the levels of abstractions. And for different levels of abstraction, you apply different knowledge. That's why I use the word stratified knowledge, right? So that is generally the idea. And there are example applications that we have built with each of these over the period of years with each of these different alternatives. Among the various issues like recency or misinformation or hallucinations, I talked about here disturbance semantics to the variety of infusion and how there is an improvement on some of these aspects. So for knowledge infusion learning, here is a generic architecture. You have data of various kind, you have knowledge of in the different kinds of knowledge, like that hierarchy I showed of the different knowledge graphs. You have your feature abstraction layer, you have your knowledge processing and understanding layer, you may also have neural reasoning layer, and then you may have workflow and process guided reasoning, because a lot of things that you do in the life I have a stepwise decision making process. If you go to a doctor, the doctor reasoning is typically aligned with what is called as clinical practice guidelines. And the clinical practice guideline says that to diagnose this information, check this, then test this. It's like a flow chart. Or if you have this result, then check this, or ask for this lab, and then you get get to the solution, right? So you need to capture that kind of things, and that's why I have this E here. Before transformers, there's this example. We have this paper in CIKM 2018, where you can see here particularly pay focus on C, because I don't have too much time. I won't be able to explain in a lot of detail. But there you see different mental health conditions, OCD, suicide behavior, or this PND, DCID. These are all various types of mental health conditions. And you have vocabularies and kind of knowledge extracted from DSM-5, which is the DSM-5 is what medical professionals working in mental health are trained on. And there are multiple such things, but DSM-5 is one of the popular ones, or widely used one, I would say. And so you're constructing the knowledge around each of these mental health concepts, and then you're overlaying it on your statistical thing, which is what you see in this metrics. So you see the green box is the 3-dimensional embedding, and this other one is from the orange one. But what you are doing here is that you are creating DSM-5. DAO stands for drug abuse ontology. So this is an ontology that we have built, very comprehensive ontology for mental health that has coverage of addiction. And you are basically changing the weights using the knowledge, and hence you are able to do better. The dark colored text, the boxes are the ones where you are improving. It shows the improvement, substantial improvement. After transformer, there have been number of approaches. One paper here is K adapter, and you see item C here in the middle bottom. They are creating what is they created adapter framework. However, they have to do a projection because the um, the size of the vector from the transformer is different than the embedding they are creating from data. Therein lies some problems in the loss. So if you have a question, the native language of Man Mary is, the answer is Malayalam, but you take Roberta, and of course is wrong. Answer is wrong. K adapter gives multiple answers with Malayalam, the correct answer as the first one. But the fact is there is only one answer. There are no other answers, right? So all these other answers are wrong. They are not just low probability. This is wrong. And these are the kind of things that such a model fails to see. There is a good example of semi-deep infusion, and there is a model called Kala, knowledge augmented language model adaptation. And here it is now K adapter can have multiple adapters for different knowledge. Here this one can only support one knowledge, but nevertheless it's an interesting framework. And problem is that it still comes out very not quite right in many situations. So the knowledge that gets applied is not done very specifically. The things that are known to be nearby in the real world may be not captured as such in the vector space that it represents. So again, let me just move on because there's a limited time. I have no idea why that stuff goes on. Okay, then there is a TDLR model that we have developed, and here what is happening is that we are able to selectively incorporate knowledge to affect the attention, and it ends up having a better handle. So you see on the top, on the bottom right, it has a much better ability to connect the concepts for World War I of different kind, where you have the big war or World War I, or 14 to 18 war, because it is war between from 1914 to 1918 and so on and so forth. So the Great War synonym, World War I and the First World War related to all these concepts here, where that kind of understanding is developed by the knowledge and is ultimately what you call ingrained in the model, right? So that is the value of that. All right, so anyway, there are some results here you can see, and I'm not going to dwell on this right now. And then there can be right now we are look at integrating lifted neural representations with knowledge graph and their application to social good. In this particular case, what we are trying to do is to see from the knowledge, from kind of extract patterns and kind of graphical information from the data and align it with the knowledge graph. And so now you are doing kind of a reverse, not knowledge, you're doing knowledge elicitation. The knowledge infusion has the challenge that when you get into neural network, there isn't any human understandable thing there. It's a black box, and you can evaluate and see that there is certain results. You are kind of making the box gray. Here now you can also try to make the box a white box, so that you can extract the knowledge from the data, align with the knowledge graphs, and then do the reasoning, including applying the process knowledge and help make a decision. So this approach may work out much better for a variety decision-making process that are multiple steps that involve process thinking. This is an important slide. Again, I like to share with you in terms of the power of knowledge for explainability. So here the text really struggling with whatever comes from Reddit. What it shows on the left-hand side, what we show on the left-hand side is the knowledge graph extracted from DSM-5. And you see that there is, modeling here that intrusive thought is part of disturbance in context of thought, content of thought is part of distribution in disturbance thinking. So the concept, words and phrases from the text can be mapped at any level, and then you have taxonomic reason, relationships, so you can do that kind of reasoning. Hence, you understand a lot more from the text than what you will understand only by having a particular, a phrase. Here, the phrase is mapped to a concept in the ontology or knowledge graph, and there is a abstraction, or there is a taxonomic information. The next other important thing is that when you want to say, let's say you classify this text as OCD, obsessive compulsive disorder. On the top right is the definition of OCD. Here now you can construct the explanation that this is OCD because it matches the definition point-wise: obsessive, intrusive thoughts, XY, and others. That's saying that, look, these data or this post instantiates all of these concepts in the definition, and that's why I'm calling it OCD, not just because it did this classification with the 0.71 probability. So I think this is the major difference for use of knowledge. There is a whole bunch of things on a process knowledge. In this case, here is a text, and then you are trying to apply CSSRS, so CSSRS, which is a Columbia Suicide Severity Rating Scale, and it requires you to ask, wish to be dead, non-specific active suicidal thought, active suicidal thought, label. If all this is the true, then the label is suicide behavior or attempt. Right, so you need to do stepwise. Look for each of these 1, 2, 3, and that is a stepwise thing. That's the process that you need to follow. So, in applying this process knowledge, and here in this case, compared to language models, large language model, use of process knowledge allowed the clinicians to have much better, agreement. We got much better agreement with the experts. So here is an example where using a language model, you can you'll have to create question to ask when you interact with the patient in language generation task. So it here created the question: do you feel irritated or self-destructive? Unfortunately, if you do that, that's not a good thing to do, because that is a negative thought, self-destruction. and that can be harmful to the patient. So here we are using our knowledge infused learning technique to improve the questions and the language for that, and say, are you bothered by becoming easily annoyed or irritable? And that avoids, they are medically safe, but they're medically valid but also safe. So this is a very important aspect, one aspect of safety. Safety is a very challenging thing. Here I want to just very quickly give you a couple of very complex applications. This is about a food recommendation. Nutrition is one of the most challenging applications that I have come across. And in this particular case, understand nutrition requires a lot of things. In this case, we are doing computer vision, segmenting, identifying the recipes, and then you want to understand cooking behavior, whether it's baking or broiling. You want to do nutrition estimate. You want in this process, there is a broad variety of knowledge that are involved: cooking process knowledge, domain knowledge, disease specific knowledge, personalized health knowledge, and all of them then lead to response to the user: eat this food, yes or no, and what is unhealthy in that, and what is the cooking method, and is there allergy? All these things have to be checked and discussed. So the things that you need to talk about is pretty complex, and the knowledge that you need in addition to your generative AI technique or language model, large language model technique, or other distribution semantics technique is also pretty nuanced, pretty complex. One final application, if you see one of the big safety problems in that letter, that open letter that many scientists have written, or even the interview with Hinton on why he quit Google, and the misinformation, the ability for people to misuse language models and ChatGPT for misuse, for disinformation is very large, very large. And then ability for us to understand whether it is AI generated or not. A lot of people are working on it. It's an interesting topic, and people are making progress, but it's a work in progress, and not, a lot more needs to be done. So here there is a fake item about Magic Johnson giving blood, but I'm showing you in this process that here you are understanding, you need to understand the person that is Magic Johnson. You need to understand the concept of blood donation. And then you need to understand the concept of hospital. Unfortunately, this won't do it. What you need to do is to, so current, the state of the art is, this 5W based question answering, 5W question answering based explanatory. So who claims, who of claims, what claims, when claims, where, and why. And all these things, there's a tool, and all this can be done automatically today. What you need is, though, think that knowledge that Magic Johnson has HIV, and that people with HIV cannot give blood donation, and that hence there's something wrong with this thing, right? So that's an example. This is fairly hard to do, but that's the kind of things that we are doing. So these are the some of the takeaways. User level explanation, and you need not just one but diverse knowledge, and you need to think about the abstraction aspect very well. Many of the top leaders in AI today have started to talk about abstraction and analogies as the next frontier. I've been talking about it for several years, including a keynote that I given many years ago. So I think the knowledge will play increasing role. If you want the technical, if you want my suggestion, one thing that you can do for more technical understanding of what we are saying, then it is this short paper in the print currently, but it's available in archive, Neuro-symbolic AI, why, what, and how. You can even Google for it, and you'll get to this thing, and that will give you more information. Here is the students that helped me a lot with this presentation, and my team and the AI Institute as a whole. So with that, I open for question. Back to you.
Thank you very much, sir, for such an interesting talk. We will take up questions now, first from the physical audience, and I would request the virtual audience to please type in their questions in the quick Q&A box. Yes, questions? So I'll quickly ask a question, sir. So one of the points that stuck with me in the presentation was when you mentioned about the Oklahoma tornado case, right? Where how AI can help people rescue, for example. So say you said that there were 2 million tweets, only 1% were those kind of tweets that ask for help. So when we want to create an automated system that works on the fly to detect those kind of tweets, what kind of external knowledge do you think is important, especially in cases where these tweets share huge amount of semantic similarity, but very few are the ones seeking help and the others are not?
Yeah, so there is a lot of knowledge or semantics that can come that can come to the rescue. One, let me start with the following. What we did, for example, was to create a knowledge about all the agencies that can provide help. So if you look at disaster coordination, the role that individuals play is very short term and very limited. For example, during Chennai floods, there's a guy who took upon himself to coordinate the medical need, like people needing prescription filled. And so he said, send me your request and I'll run somebody through the pharmacy and get you the, supplies for people who are trapped in their house with the flood, water around that. But that can be very limited. There are agencies that are there. In US, it may be FEMA, we had created. There's an interesting example during Uttarakhand floods, major floods. My organization extracted all of the knowledge from Twitter, all of the requests like this, and Google created the front end, and they credited us, and they used our data to populate the map to show the. So they could populate the agencies like Army Rescue Office for physically retrieving the stranded people. But we found all the requests for help, or and also any other spontaneous help available, and all of them were aggregated in a mashup by the thing. But coming to your question, understanding all the organizations, the hospitals, the those who are supplying water and food, those who are supplying medicine, the agencies, government agencies, and NGOs that play an important role, you need to bring that in and model. Just purely data-driven process of finding some tweet and matching with others would lead to extremely limited performance. The other thing is you need to change the, understand that somebody's asking for a particular thing, saying that I need let's say medicine, a particular medicine. they may use the actual medical term, but you need to say it's a medicine, and that this agency is in coordinating the medical supply. That kind of reasoning is also necessary, and that may not be something that pure data-driven process can give you. You also need to aggregate.
Yeah.
So you need to bring location knowledge. So we have developed an open source tool for content-based location or estimation. And then you say, in this neighborhood there is this supply, need. These people need a shelter. These people need a cluster that is not just by the need, but by geolocation, so that you can coordinate better. Again, you need to do more, and just pure data-driven thing may not work well.
Yes. Okay. Yeah. Okay. Okay. So we have an online question from a virtual attendee. So shall I read out the question? How much more effort is involved in using knowledge infusion compared to just fine-tuning LLMs with domain-specific data? Is it more restrictive than fine-tuning? There are several questions.
No, I think the fine-tuning will give you very limited thing. So ultimately, humans are making decisions to change the weights or parameter, and whatever you got from the data, you're improving that. You remember the remark I made that in ChatGPT, yeah, it was very interesting that they got the human involved, but there are 40 people. How much knowledge they represent versus years of effort that people would do to develop medical knowledge base like UMLS, or the amount of investment that goes in creating geo names, and the amount of investment that goes into creating Wikidata or Wikipedia and Wikipedia, or the amount of investment that goes in creating ConceptNet or another common sense knowledge graph. They are far, there is a lot there's a lot more human involvement, lot richer representation. These 40 people may know something or not, or one person doing fine tuning, is essentially most of the time doing guesswork. What is happening in so many papers, machine learning, deep learning? I did here is the state-of-the-art technique. I have improved upon this way, and I check with here are my 10 benchmark data sets, and here are my measures, and I get this better. And at the most they will say, I guess it is because of this.
Yeah.
As opposed to using the human knowledge. I mean, when people write DSM-5, it's a collective effort. It took 10 years to go from DSM-4 to DSM-5. And people in that domain have, deliberated, and conversed and come up with this, big guideline, big documentation. You can't have some computer scientists guess what that is, and you can't even have a single clinician guess that. Right? So the fine tuning is a nice engineering thing, far limited, compared to actually using the knowledge. The thing is very simple. Just ask yourself a question as your human brain. I hope most of you have heard about the system 1 and system 2. There is a Nobel Prize, that was given to economist, and he talked about, cognitive, inspired economic theory. Um, you make, and I have talked about, if you're interested in this area, look at my keynote on, let me see if I can um, get you, if you so if you go to let's see, YouTube and AI Institute, there is a channel on keynotes. So you just go to the first one, and this one is on semantic cognitive.
I'm very, very pleased right now to
semantic cognitive and perceptual computing. Okay, and the deep learning today, or generative AI today, is closer to what we call as human perception. Our brain is able to, our sensory, our brains get sensory information that is equivalent to 11 million bits per second. And it converts into, suppose you're reading 50 to 60 words per second, or not, sorry, characters per second. Very small amount of information. If you are asked what you are seeing, you'll immediately say, I am seeing XYZ. But most importantly, suppose an object is coming to your head, you're going to duck, and going to make that decision very fast. That's perception. But you are constantly thinking, right now during this talk, you are thinking, what is the value of this talk to me? Your brain is constantly, going in loop, round, and most of us have ability to take 2 or 3 things away. So if I were to ask you, what are the most important things you heard in this talk, most of you will come up with 3. Very few can come up with anything more than that. And that process is called system 2 process, deliberative. You are thinking, you are using your own personal context. Some of you are interested in language model, and they are asking, why is it really better than fine tuning? Others are coming from mental health application area, and they are asking very different questions. That is system 2. Our brain does this very well. The statistical AI or the neural network work is closer to, it does very fine job, and is closer to the system 1 aspect of reasoning of our brain. And symbolic AI is, a good approximation to the system 2. But in our brain, they are constantly, your brain knows what are your main interests. So what you're learning, you're going to pay focus to those. Somebody else is interested in another area, and he or she is paying attention to something else I'm saying. So there is system 1 thing that are coming to you, and you are interpreting in the system 2 context. And this is generally the philosophical reason for the class of things that we are working on. That there's many things that we do need to be supported by in many using a combination of these knowledge-driven system 2 things and data-driven system 1 things. I hope I answered the question.
Yes, sir. How do you think we can model concepts like sarcasm with these knowledge infusions? Because there is a subtle difference between malicious fake news and sarcastic ones.
That's a very good question. Actually, there is already decent progress in sarcasm without use of knowledge or a lot of knowledge. At least I was aware of the work that my good friend, who was a former IIT director, and his team did. Now he's at, of course, IIT Bombay. Yeah. So that work, I think that did decent job. More than sarcasm, the job that is even harder than sarcasm is humor. Humor detection is harder than sarcasm. 3 years ago, we looked at this problem and we saw that generative AI or basically deep learning based AI was doing very poor. And suddenly, in the last, since ChatGPT and GPT 3.5 and beyond, it is doing remarkably good job. In fact, Hinton talked about exactly the aspect of humor, and he said he was surprised. So Hinton changed the view. So Hinton has a view that AGI is, 30, 50 years ago. I have tweeted, a few years ago, it's been already, 4, 5 years at least, that I won't see singularity in my lifetime. And then Hinton has changed the view that AGI is no longer, 20, 30, 40 years, in the future, that it is, handful of years away. And one of the things that changed his mind was this of humor. And so, just the same way that Hinton changed his mind, I also reserve, the right to change my mind. But what is happening right now is, very rapidly changing things. So things like sarcasm, intention, humor, rumor, these things have been hard to detect in the past. What is happening? This is my current interpretation. Again, you ask me this question 1 year later, it may be different. What is happening is that these smart guys who are working on generative AI have understood that the data alone is not enough. I had talked about this particular concept many years ago. I used to talk about smart data and many other things in first decade of this century. But I remember a person, Pablo Domingo, a very well-known machine learning expert at University of Washington. He has a seminal paper on machine learning, and he's in that article. It's an article, invited article. Title of the section 4 is data alone is not enough. But it has taken time, because what happened is that there's 2012, which is also the year where deep learning paper came out, right? The celebrated paper, on image by Hinton and his colleagues came out in 2012. This is what got started with the neural network, deep neural networks. But the issue of data alone is not enough applies to even pre-neural network, meaning traditional machine learning also. The progress of neural network is impressive and massive. And so a lot of things that can be milked using neural network has been done, and results have been impressive for what they do, while still having all the limitations that I talk about. Now these smart people have figured out that this is not, what they do is not enough. Let me give you one, and so that is why they involve Instruct GPT and the what do they call human in the loop modification in ChatGPT. What does it do? If only data-driven thing can be done, they would have done it. No, but they have gotten human involved. I'm advocating that it's fine to get human involved, but that's not enough. Humans have already created this large knowledge graph, so why don't we use that? Okay, there is a very good analogy to this. In 1999, I started a company called Tali. And in year 2000, I filed a patent which was awarded in 2001 and this was before the very well-known paper on semantic web, where the title of the patent is semantic web for ontology or knowledge graph for semantic search, browsing, personalization, and advertisement. And then I had a commercial product, a semantic search product hosted on the website. And I had customers, paying customers, where knowledge graph powered the search. And then I went to various search companies like Alta Vista, and some of you were probably not in, were in school when this happened. These were major search companies in those days. Before Google, there were bigger search companies. And in Yahoo, and I said, look, I can do better than the traditional search that they were using based on TF, IDF and all, information retrieval based search. But none of them, well, it was very hard sell there because I was too early in the market. And they were all looking at machine learning. Google was selling machine learning. PageRank plus machine learning was very powerful. The term machine learning was very seductive in those days. But I had knowledge graph driven semantic search. Google did amazing search. All the credit to them for search. They continue to have the best product in search. But they themselves figured out that machine learning is not enough. And in year 2012 and 13, they came out with the knowledge graph driven semantic search. They did conceptually the same thing that I had in year 2000, 2001. I have two papers in 2002 that describes this thing, and you can, there is a, look at my LinkedIn, and the first article that I have on LinkedIn, I talked about 15 years of semantic search and show why the knowledge was a game changer in the search, and how, my own research and product company, and then Google and other, things. The info box that Google had, we had even more sophisticated info box than what they had 12 years ago. But the important point here is that people doing machine learning and now doing transformers are all figuring out that data alone is not enough. And one way or another, Google ended up investing massive amount of time and effort in developing knowledge graph. I was giving a keynote in 2007, the same one that I was showing you, semantic cognitive perceptual computing. That keynote was in 2007, no, 2017, I believe. No, 2017. And I was introduced by a person working at Google in Google Knowledge Graph. And he told me that Google had 10,000 people building that knowledge graph and maintaining that knowledge graph. A lot of editors, a lot of humans. So Google found it to have enough value to invest in this knowledge graph. And then while generic public and business public gets excited by things that can be automated, using machine learning, deep learning, generative AI, transform model, and everything that we can do on GPU clusters. The smart people have seen the limitation of data alone techniques and have started to involve either humans or use knowledge. The same ChatGPT that currently uses these humans, they started with 40, I don't know how many they have now, and they have some cheap labor in Africa, are going to keep on increasing their use of knowledge, whatever they call it. So I think that thing, I'm pretty sure, is going to happen. And I think I will share it just the same way. I hope I'll be right in the same way. In year 2000, I had knowledge graph driven semantic search. I hope that you'll see a lot of this, what we talked about today, in future, a lot of use of knowledge. So, I mean, it's very simple. I think both of them are complementary. It's not like knowledge graph and symbolic AI will replace generative AI or transformers. They do not. It's very powerful and it does something very well. But it does complement things where all these problems like hallucination and safety. So one of the major area of my research now is developing guardrails using knowledge for safety, right? And I hope those you'll understand that you will have you get a sense that why knowledge can be very important to create guardrail. You see, you can't create guardrail just by probabilities, because it is the problem you have is because you are only reliant on probabilities. You need guardrails by grounding it in the real world, right? If you take that example of Moshe Verdi, Bard saying Moshe Verdi died at 75, it's very easy to take that answer, parse it out, and check against Wikipedia. And Wikipedia says that it does not say Moshe Verdi has died. So you'll be able to make this system safe in that Wikipedia. Using that knowledge, you would know that you will not, this thing, is very suspect. It's possibly wrong. If you want to consider Wikipedia as a more authoritative source, then let's correct it and say, not give Moshe Verdi has died at 75. Right? Okay. All right. I've taken a lot of your time. I'm more than happy, but I am sure you have other things to do.
Yes, thank you so much, sir. Thank you so much for your time and support for this event. It was really, really wonderful having you here and listening to your talk. Thank you so much. A big round of applause for Professor Amit Sheth. Thank you, sir. Thank you so much.
Bye.
Yes. So announce that we are not going to have any break, Yeah, announce.
Dear all, in the interest of time, now we are going to introduce our next speaker, and we'll start the talk just now. So we have Dr. Prasada who will speak. First check.
Yeah. Ina, can you share the screen? We have made you co-host. Maybe you can check. Yeah, we can see. So first, let me give you a brief introduction for you, then you can start, maybe.
That's good.
Yeah, here we have Ina Wanyin Lin with us. So she will talk about human-centered NLP for mental health. I hope I am pronouncing your name correctly.
Yeah, it's right. Thank you.
So she is a PhD student in the Paul T. Allen School of Computer Science and Engineering at the University of Washington, working with Professor P. Maltov. Her research focuses on natural language processing and human AI collaboration for health and social applications. So before joining PhD, she has worked in JP Morgan as a quantitative analyst. She has received Merlin Prize Endopresental Fellowship and the WWF 2021 Best Paper Award. Ina's research has been covered internationally by news outlets, including the Wall Street Journal, the Washington Post, NPR, Deutsche Bahn, and Infobay. Thank you. The stage is yours now.
Thank you so much for the kind introduction. Hi, everyone. I'm Ina. I'm a PhD student at the University of Washington. My work focuses on NLP and machine learning for human well-being, and I'm here to talk to you about human-centered NLP for mental well-being today. Before I start, a quick content warning that this talk contains anonymized examples related to mental illness, self-harm, and suicidal ideation. Mental health is a global health issue. In 2019, 1 in every 8 people was living with a mental disorder. This is 970 million people worldwide. And however, most people don't actually have access to effective care. There's a global shortage of mental health professionals. As a matter of fact, there's only 13 mental health workers per 100,000 population in 2020. And moreover, what makes it even worse is that many people with mental disorders also experience stigma, discrimination, and violations of human rights. Since language is such a central part of psychotherapy and peer support, Many have developed NLP models that help address the global health challenge. And these NLP models and applications should be human-centered, since they're developed for the humans involved in psychotherapy and peer support. And the humans that I talk about will include peer supporters, patients or support seekers, therapists, and so on. And they need to these applications need to focus on the needs and preferences of the people rather than solely focusing on the technology capabilities. And the applications also need to be user-friendly, accessible, and inclusive. And today I'll talk about our two recent projects that address human-centered NLP in these two aspects respectively. I'm focusing on the needs and preferences of the people. I'll focus on one aspect, which is empathy, which is proven to be a preferred and more effective way mental health support should be provided. I'll talk about our recent paper in Nature Machine Intelligence, which is called Human AI Collaboration Enables More Empathic Conversations in Text-Based Peer-to-Peer Mental Health Support. And on designing more user-friendly, accessible, and inclusive applications, I'll talk about our recent work examining gendered mental health stigma in masked language models. These models are often used in downstream applications related to mental health, especially some of the predictive modeling. So without further ado, I will dive into the first part. This work was done with Ashish Sharma and my advisor, Tim Althoff, as well as our domain expert collaborators, Adam Miner and Dave Atkins, with strong support and involvement from TalkLife, which is one of the largest social network actually based in the UK, focused on mental health, also where we recruited our peer supporters in the study. As we talked about earlier, there is a global shortage of mental health workers or professionals, and peer-to-peer support platforms can be a solution to this problem. And what exactly are these peer-to-peer support platforms? So they are a place where you can find people that often share your experiences and maybe understand what you're going through. And millions of people seek and provide support through these online platforms. And these platforms serves as a complement or only form of support for many people. Examples of peer-to-peer support platforms include TalkLife, 7 Cups, or some of the mental health related subreddits. And the success of these peer support platforms rely on the quality of the support. So quality support will require a range of skills. And in this work, we focus on empathy as a central enabling factor. Empathy is defined as the ability to understand or feel the emotions and experiences of others. And empathy is actually highly nuanced, and expressing empathy requires expertise and training. Most peer supporters on these online platforms are typically untrained and unaware of empathy and other best practices in counseling. And this gets reflected in their conversations, as we find that highly empathic conversations are actually pretty rare on these platforms. And in this example, you're seeing if the seeker says, "My whole family hates me," a peer supporter may say, "Try talking to your friends," which is a strategy often used by peer supporters, to suggest actions the seeker can take. And that is actually not the most effective way of providing support. Empathic and more effective response would be, I could imagine that this would make you feel really isolated. So the key question we want to address in this work is, how can we improve empathy in peer-to-peer support? How can we turn these low empathy response on the left into higher empathy responses on the right? And our hypothesis is that peer supporters may express higher empathy if they receive AI-based feedback that are automated, actionable, and just in time. And we want to build computational methods that can facilitate and generate these feedbacks. And in a series of works done in our lab, leading to the one that I will talk about today, we have examined how to measure empathy, how to generate empathic response, or rather, rewriting a low empathy one into a higher empathy one instead of generating something from scratch. And also finally, human AI collaboration on empathy. To develop these computational measures of empathy, in a previous work, my done by my colleague Ashish Sharma in the lab and other collaborators. They adapted existing scales for empathy measures based on a series of psychology literature. And they also focused on adaptation to exclusively text-based asynchronous communication, and also tried to capture both emotional and cognitive aspects. And more concretely, they developed this framework. So the framework of empathy defines 3 different mechanisms. First of all, emotional reactions, which is about communicating the emotions such as warmth or compassion felt after reading a post. Second, interpretations, which relates to communicating an understanding of the inferred feelings and experiences. And finally, explorations, where one improves their understanding by exploring feelings or experiences. And for each of these mechanisms, they have 3 levels, which differentiate between peers not expressing them at all, which is level 0, expressing them to some weak degree, level 1, and expressing them strongly in the conversation. And they develop an NLP model to identify these levels and extract rationales behind, the identification of the levels. And let's understand this better with the help of an example here. So a seeker post, "My whole family hates me. I don't see any point in living." A response like, "Let me know if you want to talk," is actually doing neither of the 3 and is actually not very empathic. And the next couple of examples that you see here are more empathic, but they're all expressing empathy to a weak degree. For example, weak interpretations, "understand how you feel," or weak emotional reactions, "everything will be fine." And here, weak explorations, "what happened? Let me know if you want to talk." And here are some of the strong, empathy examples. Strong interpretations, "if that happened to me, I would feel really isolated." Or strong exploration, "I wonder if this makes you feel isolated." A strong interpretation would interpret that if the family of the seeker hates them, it could make them feel really isolated, and also communicates the same in the response. After coming up with a computational framework to measure empathy, a follow-up work we did was to design a collaborative approach where an artificial agent gives feedback to these peer supporters. In this work, we introduced empathic rewriting, which is a task to computationally transform low empathy conversation posts to higher empathy. And for example, given a post from a seeker, "I can't deal with this part of my bipolar, I need help." And a corresponding low empathy response would be, "Don't worry, try to relax, anyone you can talk to." And we want to increase empathy in the response by transforming it to, "being manic is no fun, it's scary, I'm sorry to hear this is troubling you, try to relax, anyone you can talk to." So the rewritten response should communicate more empathy through understanding of feelings and experiences. "Being manic is no fun, is scary," which is the interpretation dimension, and display of felt emotions. "I'm so sorry to hear this is troubling you," which corresponds to the emotional response dimension. And we proposed this model called Partner. We use standard reinforcement learning setting with the states, actions, policy, and rewards. And in our setting, Partner works on a conversation between a seeker and peer supporter. So it first extracts the state from the conversation. Based on the state, it performs a set of rewriting actions using a policy, and finally get some reward for training. And Partner is rewarded for these 4 key components. First of all, increased empathy with the help of the framework that we developed earlier. Also fluency in English, a coherent response. Also, we want it to be very context specific. So we try to avoid very generic responses like, "I know how you feel," which is not the best way to express empathy. And our model outperforms, general purpose state-of-the-art NLP models on empathy and specificity. And now this leads to the human AI collaboration work in the series, which I will focus a little bit more today, how to collaboratively improve empathy. And I'll show you our attempt of designing the system. So let's dive right into our system, which is based on the hypothesis that peer supporters may express higher empathy if they receive AI-based feedback. And let's say a seeker post, my job is becoming more and more stressful with each passing day. Now, without any feedback, I will be presented with an empty chatbot to write my response. So maybe I'm not very good with providing support, and without feedback, I don't really know how to proceed. So I'm only able to write something like, "Don't worry, I'm there for you." And this is where AI could help. So we design a system which can give feedback to peer supporters based on empathy in real time. And the system prompts peer supporters through a pop-up. Would you like some help with your response? This is right above the response text box. So I need some help with my response, and all I will do is click on this prompt. And when I click it, the AI will take the seeker post and my current response as input, and it would assess how empathic it currently is, and will suggest changes that can be made to the response. So in this example, the AI suggested me to replace "don't worry" with a more empathic sentence. It must be a real struggle, and suggested to insert, "Have you tried talking to your boss?" at the end of the response to further explore seekers' feelings and experiences. There's also this little reload button through which I can also load a new suggestion if I need one. And I can accept these suggestions by clicking on these actions buttons, and can continue editing the response and seek more feedback if I want. And to evaluate our system, we conduct a randomized controlled trial with peer supporters from Talk Life. We recruited 300 participants from Talk Life and randomly divided them into control and treatment conditions of human only and human plus AI systems. Participants then write response to 10 existing seeker posts in total. And we have different set of these 10 posts for different participants, but same posts across treatment and control. So our main findings is that feedback does lead to conversations with higher empathy, and we evaluate this in two ways. First, using a human evaluation where we ask an independent set of Talk Life users, so separate from the participants in the study, to compare human only and human plus AI responses. We found that the human AI responses are rated more empathic than human only responses 47% of the time, and human only responses have only 37% preference. We also do a complementary automatic evaluation using one of our previously validated empathy classification framework that we talked about earlier, and find that the average expressed empathy score of human AI responses are roughly 20% higher than that of human only response. We also collected perceptions of participants about our approach, concretely on the usefulness and actionability of the feedback and their intention to adopt such a system on peer-to-peer support platforms. Because if you have a model that performs really well, but people don't really want to adopt it in real life, then it wouldn't be really helpful. So in a very, very exciting result, a clear majority of over 77% participants actually wants to see this type of feedback system deployed on Talk Life. Over 60% participants find that the feedback is actionable and helpful. And more than 69% participants reported increased, self-efficacy. So they report feeling more confident at writing supportive responses after our study, which indicates the potential value of this system also for training and increased self-efficacy in the slightly longer term. And in general, participants who consulted and used AI more often expressed higher empathy, as shown in this plot. So we look at the expressed empathy scores of people who, did not really consult AI during the process, who consulted only once, consulted but not used, consulted and used, always consulted, always used, and so on. So you see an increased level of AI consultation or usage. On the x-axis, we find that people who have a higher level of AI consultation or usage also have higher expressed empathy scores. if you look at the green dot, like on the left, a substantial number of participants also chose to never consult the AI in the process. And such participants actually, they expressed the least empathy in their response, which is around 1.1 on average out of 6, suggesting that consulting the AI could have been beneficial. And to develop applications in high-stake domains like mental health, it is really crucial to consider the ethical and safety aspects. AI technologies in mental health creates opportunities and risks at the same time. And safety and welfare of participants always comes first. Any potential risk needs to be considered and navigated for sure. We follow the ethical framework by Camille Nebeker and others at Recode Health that inform the concrete actions that I'll tell you about next. So first, it is critical to our success to co-design with stakeholders to minimize risk. And of course, this also creates benefits. We collaborated with platform designers, platform users and clinicians throughout the design process. And secondly, we reduced risk by intervening only on peer supporters and not the people in acute crisis. Last but not least, we have focused scope on empathy feedback, and we didn't want to build a general chatbot. And empathy, of course, is an evidence-based intervention. And in addition, in our design rationale, we want to make sure that human-human connection always comes first. And this is actually not only human in the loop, it's actually AI in the loop. We want to give only minimal feedback, only when needed and requested. And we do not show response to people in crisis. Again, we develop realistic sandbox environment instead of immediate deployment in the wild. And this gives us and the stakeholders opportunities to study safety implications first. Also, peer supporters did catch a few cases where the feedback was not, appropriate or could possibly have led to adverse events. Having the human-AI collaboration process also ensures that we're able to flag these cases for future studies and before showing them to people in crisis. Additionally, participants had access to crisis hotline during the study, and they could quit at any point if they want to or need to. Some ethical considerations was actually integrated into the AI objectives. So in our design rationale, we made sure to do a rewriting task that tries to keep what the peer wanted to say in the first place instead of crossing everything out and start something new. We aim for minimal feedback and for only when the peers need it. So in this way, we do not discourage people from supporting each other. And of course, we also acquire informed consent of all participants. And the study was, of course, IRB approved. Of course, we also, there are more and more computational models built in the digital health space. More future work is needed on these ethical principles. To recap the key takeaways from our empathy line of work, first of all, empathic conversations are crucial for effective online support, but currently empathy is expressed rarely online. Our work proposed new computational tasks, data sets, and tools that can be used for facilitating empathic conversations based on state-of-art NLP techniques. And as part of our study, we conducted randomized trials to show that human-AI collaboration on empathy can be effective, actually more effective than AI-only or human-only approaches. So now I will shift gear a little bit and talk about the second aspect of human-centered NLP, building user-friendly, accessible, and inclusive applications. And today I'll actually focus on the inclusiveness a little bit more. I'll talk about our recent work examining the gendered mental health stigma in mask language models. And these mask language models have been used to develop many downstream applications related to mental health. And if they contain bias, it is likely that the bias will be perpetuated into downstream applications, which will affect the inclusiveness of the applications. This work was done together with my co-first author, Lucy Niu, and other collaborators in our lab, B-Data, and Professor Yulia Svetkov's lab, Svetkov at UW NLP. As we said earlier, mental health is a really prevalent issue, and it is also heavily stigmatized, which prevents people from seeking help. And what does gender have to do with it? Well, the mental health stigma is actually different for men and women. Psychology research has shown that mental health tends to be more associated with women while being overlooked for men. And what exactly is mental health stigma? So we define it as the stereotypes that society has towards people with mental illness. And in psychology research, stigma is broken down into 9 dimensions, which are listed in this figure. They include things like blame, anger, pity, help, avoidance, fear, and so on. What does all of this have to do with NLP? Well, NLP is already being used in lots of mental health settings, like in mental health support chatbots. But in recent NLP research, language models have been shown to capture social biases in their training data, such as associating criminal with Black or police with white. So if mental health stigma patterns are encoded in language models, they could potentially reinforce harmful stereotypes and cause disparities in ways men and women are treated in mental health. So here is an example. Let's say we have a support chatbot and the user says, I've been struggling with anxiety. And when a user introduces themselves with a female name like Sarah, it says, Sarah, I'm sorry you've been struggling. Have you considered seeing a therapist? But if the user introduces themselves as John instead, and then say the same thing, the chatbot may very likely say, you know, John, things will be okay in the end. I hope you feel better soon. And there are a lot more ways this could show up. For example, models that generate stories might only make up stories where women are in therapy. And models that help clinicians diagnose people might diagnose men and women differently, and so on. So in this project, our objective is to explore whether language models capture those same gendered patterns of mental health stigma that we see in society. And the spoiler alert is they do. But the point of this paper is not to tell you which models are bad or good, because it is highly dependent on the context of use, whether it is a chatbot related to mental health or a tool to help with clinical diagnosis. What we try to show in this work is, the trade-offs, advantages, and disadvantages of a variety of models that we tested. How we can use theoretical grounding from psychology research, and also the importance of intersectionality when examining bias. And the general idea of our methodology is to construct a set of prompts related to mental health that have the subject mask out, such as the example shown here, blank has depression. Then we use a masked language model to fill in the blank with a pronoun, a noun, or a name. We're using masked language models here because they provide a more concrete and controllable framework. We then compare the likelihoods of the model filling in with explicitly female versus explicitly male words. So if words indicating female gender are consistently more likely to be generated than male, then that would imply that mental health is more associated with women than men in this model. And we repeat each prompt 11 times with the 11 most common mental health diagnoses defined by the National Institute of Health in the United States. It includes depression, anxiety, schizophrenia, PTSD, bipolar, borderline personality disorder, OCD, panic disorder, anorexia, bulimia, and psychosis. And these are all diagnoses that both men and women struggle with. And we made sure not to include diagnoses that would naturally be much more common among one gender than the other. For example, postpartum depression, which we didn't include. And we do all of our experiments with 3 different popular models that are pre-trained in different ways. First one is Roberta, which is a general purpose model. And then we have Mental Roberta, which is based on Roberta, but pre-trained specifically on mental health data. We also have Clinical Longformer, a model trained on medical data that isn't necessarily about mental health. And overall, we have 2 sets of experiments for these 2 research questions. First, we want to look at gender, a general gender association. So do language models prefer a certain gender in sentences about mental health? And how does this vary as sentences express different stages of treatment-seeking behaviors, which I'll talk more about shortly. And then secondly, we look at specific dimensions of sigma to explore whether language models associate different attributes to men and women with mental illness. And we'll dive right into the first one. So for this first research question, we created a set of prompts that cover 3 healthcare seeking phases based on a psychology concept called the health action process approach. So the first stage is diagnosis, which is where a person has acknowledged that there is a problem, but they haven't done anything about it yet. And then the second stage is intention, which is where a person wants to and is planning to get treatment. And finally, we also have action, which is where a person has actually taken the steps to get help. And these are a few examples of prompts for each stage. For example, diagnosis include things like blank is diagnosed with anxiety, blank struggles with depression, intention includes someone is looking for a therapist or wants to get help. Action includes, someone seeing a psychiatrist or someone's in treatment for a condition. And here are our main findings. So first, we look at overall female word probabilities and male word probabilities. So we find that Roberta consistently predicts female subjects with a much higher probability than male subjects here. And that reflects the societal pattern of associating mental health more with women than men. And next, we also look at the gender disparity across health action phases. And we find that it increases from the diagnose stage to the intention stage and then to the action stage. And again, that encodes the societal pattern of men being less likely to seek care and even less likely to actually receive it. And then we compare the behavior of models that were pre-trained in different ways. We find that gender disparity is much smaller in mental Roberta than in Roberta. And in this case, the domain-specific pre-training of mental Roberta seems to have effectively reduced some of the bias. And if you're interested, we have more details in the paper. But for now, we're going to move on to the second research question about specific dimensions of sigma. Our methodology here follows pretty much the same process, but we constructed the prompts pretty differently. So the prompts came directly from this AQ27 questionnaire. This is a standard survey in psychology research that tells a story about a man named Harry with schizophrenia. And then they ask a bunch of Likert scale questions to evaluate the survey takers' level of sigma towards people with mental illness. And we rephrase the questions into descriptive sentences about, some person with a mental health condition, and again, mask out the subject. So for example, on the right, I would feel aggravated by a mask who has depression, or I think a mask with diagnosis, poses a risk to the neighbors unless hospitalized. And some prompts in this set describe very specific situations. So the probability of generating a single token that happens to be a gendered word, like father or mother, or men or women, is pretty low compared to non-specific gender subjects like friend or a person. So to reduce the sparsity of the gender subjects, we designed this recursive procedure that enables us to gender multi-token noun phrases. So for example, if I give the model, I would feel aggravated by a mask who has depression. And the model filled it in with friend, which is a non-specific gender word. We would recursively create another prompt that adds the mask token as a modifier. So before the word friend, and then the model would generate male friend, which is then gendered. And our most notable findings for research question 2 are that both Roberta and mental Roberta predict that men with a mental illness are more likely to be avoided and less likely to be helped by the public than a woman with mental illness. And that's once again in line with the real world patterns of mental health stigma. And secondly, mental Roberta predicts much higher likelihoods for women with some dimensions of stigma. And interestingly, women are more likely to be blamed for their mental illnesses and to receive more anger from the public because of their mental illnesses than men. And we discuss other dimensions of stigma in greater detail in the paper. So please check it out for further analysis. Okay, so given all of these results, what model should I use then if I'm making a mental health application? So our results actually do not point to a single model that is better than everything else because there are trade-offs, advantages and disadvantages for each model. And for example, we saw that Roberta preferred women over men a lot more drastically than mental Roberta, but mental Roberta also associated particular stigma dimensions more heavily with women than with men. So what the model behavior should be depends on the downstream applications. So the different aspects of mental health stigma explored by research question 1 and 2 may be more or less important in different contexts of use. So for example, if we have a model that helps clinicians diagnose people, maybe we care more about gender association and treatment seeking behaviors because we're concerned about overdiagnosing one gender and underdiagnosing the other or another gender. Or on the other hand, if we are making a mental health support bot that chats with people, maybe attributes, describing specific dimensions of stigma is more important because we don't want the chatbot to make assumptions about the character or personality of different genders with the mental health issues. And importantly, our paper demonstrates using theoretical grounding for problems that are inherently interdisciplinary and reach beyond NLP. So our framework for identifying and evaluating bias in NLP models is grounded in social psychology research on mental health, on stigma, and treatment-seeking behaviors. And there's a lot more language-focused psychology resources like AQ27 questionnaire, which we used, and that literature can be leveraged for theoretically grounded NLP research on mental health. And additionally, this project shows the importance of considering intersectionality when looking at bias in NLP and other machine learning settings. Intersectionality is this idea that different aspects of a person's identity interact to create unique kinds of marginalization. And here we're talking about gender and mental illness, and our framework is a general one that can be used to study any dimensions of identities. In many cases of bias research, women are disadvantaged. However, in the intersection of mental illness and gender, men's mental health is more likely to be overlooked. So if we had assumed that it's always women who are disadvantaged in every context, we'd be perpetuating the stereotype that are ultimately harmful for both men and women. And intersectionality is increasingly important in high-stakes settings, like healthcare, because applications can directly affect people's life. And of course, there are many avenues for future work building off of this project. And here are a few important ones. First, we want to be able to include non-binary and genderqueer identities in our analysis. Currently, we only focused on binary genders because of the lack of annotated data on these non-binary gender identities. And second, there are many other intersectional identities for which it would be interesting and important to explore bias, for example, race, age, socioeconomic status. For example, actually in undergrad NLP classes at our university, students have been using our framework to also look at stigma related to race. And mental health is not just different for men and women, but it's also different for example, white men and Black men. Finally, in this work, we focused on intrinsic harms, and it will be very important in future research to understand the extrinsic effects of these models when they're used in downstream applications. So to recap, I talked about two aspects of human-centered NLP for mental health, and like for each of these, I talked about a recent work of ours in each of these aspects, and there are definitely more related work and future work in this area that I'm really looking forward to reading and working on. Thank you for listening for the talk, and I'm happy to answer any questions.
Thank you for the talk. If anyone have any questions from the physical audience, okay, so you have one question from the physical audience.
Thank you for a very nice talk. For the first work you mentioned you train a reinforcement learning agent. I just want to know a little bit more details. You mentioned the reward function, right? It seems like you only give positive reward. Did you give any negative reward? Also, have you tried different reward functions? Because I assume that different reward functions might highly affect on the final performance of the RL agent, right?
Yeah, so thank you for the question. It's a really good question. I didn't go into like too much detail on the reinforcement learning agent, but I can definitely talk a little bit more. Let me just try to find that slides, make it easier. So to answer your question, we did try a bunch of different reward functions. We didn't try negative awards. I don't think we tried negative rewards, but we did try different reward function for each of the the aspect that we identified. So I think what we did was we identified several important factors that we think are crucial in the in this model. Sorry, one sec. Let me try to find that here. Yeah, so so the rewards we used include these four different components, and for each of these components, we tried different reward functions based on previous research, as well as we came up with our own version of, for example, specificity, and like we selected the ones that we computationally and qualitatively found to be the best.
Thanks. Another quick question. Have you tried training this AI in real time, like learning to improve it based on the feedback or the response from human?
That's also a good question that we thought about when we were working on this project. We did not do real-time training for this one, but I do feel like it could be an interesting question to explore in the future, especially like in real time deployment. And I think it's also interesting to think about kind of like as the peer supporter, sometimes they would flag, if they think it's inappropriate or it's not helpful enough. And from that aspect, it could also be interesting to look at real-time training, but for this project we didn't do real-time training.
Thank you. Any other questions?
Thank you very much for a nice talk. I just have one question about the empathy generation task. So when you're generating this empathetic responses, is it the case that the agent should actually come back and ask a few more clarification questions? For example, if you say, I'm stressful with work, rather than...
Sorry, do you mind talk a little bit? We're slower.
Yeah, so for example, if somebody asks, I'm stressful at work, and rather than quickly jumping to respond with, I understand your problem and so on, should the agent actually ask two questions, like why are you stressed? Is it because of X, Y, Z? Give some more information, and to try to, like provide actionable response rather than a kind of a canned, like pre-generated, like artificial response.
So
the case that like the agent is asking some questions before generating responses. So
Sorry, let me repeat the question so that I make sure I understand it. So are you saying should a good response be actually providing a suggestion on an action instead of just showing empathy? Or like maybe the person was seeking help.
So before generating a response, should the agent ask some few more clarification questions?
Yeah, it's actually one of the aspects in our empathy framework, which is exploration. So, you know, if someone said, I feel really depressed, you know, to show, like, one of the aspects that, one of the ways to show empathy is also to explore the feelings and experiences. Why were you depressed? So it's kind of, I think what, like, getting more information is part of the framework. And regarding like, you know, information seeking behaviors, it is helpful, but like in some of the previous psychology research, it is shown that, you know, by only providing an action suggestion isn't the best. So like, you know, empathy is like this really important, it's a really important factor to provide, you know, effective support. So even if someone is providing, you know, a suggestion for action or something, you still want to show empathy. So like, so in that case, our model could also help to, you know, like keep what the peer supporter was already saying. So for example, if the peer supporter thinks that, you know, like suggesting an action is helpful here, we're not trying to like scratch that out. We're just trying to help them, you know, expressing the same meaning, but with more empathy. So I think this question also touches the another aspect which is, you know, incorporating the expertise of the peer supporters. So like if the peer supporter thinks that it is actually a good strategy to suggest action in this conversation turn, then, you know, our model help you improve the empathy in the response, but keep what you were already, you know, wanted to say. I don't know. Yeah. Yep.
Any more questions?
I think there's a question on the chat. Sounds like this project is based on a lot of theoretical knowledge, all about collaborating with the domain professionals. Thank you for asking this question. We did collaborate with domain professionals throughout the whole process. Our two of our co-authors are in psychiatry and psychology, behavior science, and we also co-designed this with designed professionals at Talk Life, which is this platform, like for social platform for mental health support. So, you know, we did collaborate with Domain X professionals, and we made sure that, you know, yeah. Thanks.
Thank you, Anna. So I had one question, not actually a question, just I wanted to hear your comments on that. It is related to past work. So what you are doing in this work is like the peer supporter is providing a response and the model is actually including empathy into that response. So actually it is kind of improving the quality of support, right? In the first work. And you said like you didn't go for like chatbot kind of thing where the output will be automatically generated, right? So initially also talked about there is this shortage of peer supporters for this kind of problem. So what do you think would be the best way? Because automatically generating response, you are saying that is too risky. And here you are improving the content that I understand. But still in that case, we need the peer supporter, right? To provide the response and then it will improve the quality. But I mean, like, can you share some thoughts on your idea that what can be the midway to solve this shortage of peer supporters or that kind of thing? Because you're saying completely automated thing can be risky. That's why you just
that is a very good question. I don't have a good answer. I think if I do it, the problem will be solved by now. But I think the problem has two parts. One is that there is a shortage of in numbers. So like there is not enough professionals. And another aspect is for the current peer supporters, they're also undertrained, and they're not able to provide as high quality as the response that they can, and they potentially can. So maybe they're like two slightly separate problems. And our project, of course, helped to improve the quality of the peer support, responses. And because I think it also helps with the number of mental health professionals, because anyone can be a peer. Like I can be a peer, you can be a peer. If if we help more people around us to be able to provide a better quality response, then we kind of increase the number of people that can provide help. So I think it's it is a really good question to think about. But I do feel like peer supporters kind of really helps with to fill in the gap between people who have no support at all and people who are able to access professional help. And by increasing the number and increasing the quality of peer support, it could mitigate this gap.
Thank you. Thanks for the wonderful talk and also the wonderful answers. Thank you. Thanks a lot. I think with that, we are wrapping for today. Tomorrow we have 2 talks, and tomorrow's talk starts from 10 a.m. Thank you. Thank you everyone for the cooperation.